post-traumatic brain injury, it seems pretty obvious that at least with the closed head injury model, one of the tissue that gets directly hit is the skull, on top of the skull. So we also have some evidence from the literature that shows that there are direct primary afferents that goes from the trigeminal ganglion that project into the top of the skull. So the tissue directly on top of the skull is called the periosteum, and that kind of we wanted to put two and two together to kind of see how the tissue would play a role in either generating or maintaining or in persistence of post-traumatic headache. What we've shown so far, and this is work in progress, is that in rodent model of post-traumatic headache, so after we impact the animal with traumatic brain injury, we've seen that oxytocin receptor expression increases in the trigeminal ganglion compared to the animal that did not receive the impact, which suggests that there could be the receptors modulation could play a role. And we have also shown that injection of a retrograde tracer on top of the periosteum or into the periosteum directly labels neurons in the trigeminal ganglion, and those neurons co-label with oxytocin receptors when we stain for it in a tissue in a rat model. So this suggests that there is a direct connection from the afferents that are projecting to the periosteum that also co-labels with or co-expresses, or those neurons that are projecting the periosteum co-expresses oxytocin receptors. So it could be suggesting that it could be a good target for oxytocin injection. And lastly, we've shown that direct oxytocin injection into the calvarial periosteum after a traumatic brain injury significantly reduces traumatic brain injury-induced allodynia in rodents. And this is short-lived, so it's, the effect stays for about 1 hour post-injection. And we have also shown that this could be reversed when we inject oxytocin receptor antagonist, showing that the mechanism of action is via oxytocin.